So let me just go through. This slide is for the our collaborations with foreign universities like Trinity College Dublin, Tel Aviv University, and other university, which Dr. Batish has again touched upon. Okay, so coming to the electronics and communication engineering department, we run 3 undergraduate courses. One is BE in electronics and communication engineering. The second is electronics and computer engineering. And third program, which we are starting this year, is electronics engineering with a specialization in VLSI design and technology. We also run programs at the postgraduate level. One is I'm a Master of Engineering in Electronics and Communication, and one MTech program in VLSI design. And we, of course, recruit the PhD students also. We have a teaching staff of 64 faculty members, out of which 4 are at the professor level, 11 are at the associate professor level, 48 are assistant professor level. And most of the staff is PhD, holding PhD degrees, and they are from very good institutions like IITs and NITs. And some faculty members also have joined us from after studying from abroad. So I will now come upon to some of the trends which actually govern the electronics, computing, and the communication part. That's why I call it that when you will study these things, it will be a transformative experience. You have to actually watch for 5 trends in the industry. The first is the launch of 5G, and which will unlock new opportunities, because 5G, you must have seen on television also, our Prime Minister launching 5G technology, in which the Reliance Group was also present, and the other top leading telecommunication companies were present. Then second trend to watch upon is the wider proliferation of artificial intelligence and machine learning. Emergence of cloud and edge computing. Then change of gear in automation and Internet of Things. The fifth important trend to be watched upon is the growth in the VLSI and the semiconductor chip industry, chip manufacturing, which in the budget session, full money is allocated in the I'm talking about the central budget. Now, if you look at the global 5G adoption to hit, this is the data I'm trying to explain, which is the global data. And if you look at the data says data goes from 2021 to 2027. And this data pertains to the all over, it's a global data, not India specific data, and see how the 5G growth will happen and how in terms of the number of devices, the devices will increase. One thing I actually want to stress upon is that so that you can appreciate 5G technology, is that see, you have everybody has got the smartphones or mobile phones with them. So you see 2 signals on the mobile. One is a Wi-Fi signal, the other is a cellular signal. Now, the major growth that has happened till now in the broadband technology or in the data transfer technology is coming from the Wi-Fi technology. But if you look at the other signal which is coming on your phone, which is, let's say, 4G signal or 5G signal, the growth has not happened, till now, because the major players in the global industry were not ready to invest money into the telecommunication networks, because you cannot download 1 GB of data or 1 complete movie within seconds when you are on a 4G network. All this data transfer you can do when you are in the Wi-Fi network. So Now the global industry has decided to, to invest in the 5G technology or other, changing the complete infrastructure for the telecommunication network. And that's why I'm saying that the growth in the 5G technology will happen very quickly, and a large amount of things will happen in the 5G technology. So this is the first area which one has to look upon, which I just explained in this slide. The other important thing is the artificial intelligence. So this is how you can see that the investment coming in the $1 billion, how it will increase into artificial intelligence and machine learning kind of things, which will actually change the scenario of the whole India, which is the kind of revolution that will happen in the Indian industry. And if you see how the growth is happening and how this actually graph explains how the money being invested in different in this area year-wise, and it's a huge exponential growth that is happening. Why I am presenting these slides? One, the first slide was the 5G technology, now it's the artificial intelligence, because I want to just stress upon the kind of teaching that will happen in electronics and communication engineering department, offering 3 programs. Now, one is ECE, one is electronics and computer engineering, the third one is the VLSI. And all these 3 programs are actually tailored to meet these demands and this growth story that will happen in the coming years. Look at the emerging trends that are happening in AI and machine learning. For example, there is generative AI. Generative AI, you can compare it with the ChatGPT or the other latest, chatbots that are coming into with your phones also and otherwise. Then IoT. See, everything, every machine, every electronic gadget has to be on internet. That's what is called as the Internet of Things. That will happen with the overlap of the artificial intelligence and IoT devices. Augmented intelligence, then algorithmic decision making. So all this, the trends and the technologies that I'm talking about will happen in the coming years only. And the department has equipped itself with the infrastructure and with the kind of curriculum to deal with all these things. Then look at the IoT market, that is, look at the IoT market. See, this is this is how the things will exponentially grow again in the IoT market. Starting from 2019, it goes to 2027, and how the growth story will happen. That's how this graphic, the IoT security, IoT hardware, IoT services, IoT software, all these things require the manpower, the trained manpower, which the department and the Thapar Institute is, hoping to develop. The students should be equipped with all the stuff, all the knowledge, all the hardware requirements, hardware knowledge, software knowledge, so that they can, enter into the market. Then this is about the the edge computing, the cloud computing that will happen, because everything has to go to the cloud. And look at the compound annual growth rate starting from 2021 to 2029. So that's again that this graph is again showing an exponential growth, with a growth happening about 38.2% from 2021 to 2029. And the important thing, which this slide when I present this slide, the important thing to be seen here is that see this part. This blue part is the services part. The orange part is the solutions. The gray part is the hardware part, and this yellow part is the platform part. The other, see, the traditional computer science and engineering branch may deal with this services kind of jobs or services kind of, industry. But if you study electronics, the communication part and the software part, the computing part, so you will be also, you can also be absorbed in the solutions industry, the hardware, which is a very important part of the industry where the engineers will be required, who can design, who can do the R&D. This part is especially will be taken care by the people of electronics and computers, electronics and communication, and especially the VLSI industry. I will come to the VLSI slide also. Then this is about the the VLSI design part. This is about the, again, I need not to explain the amount of growth that is happening if you go in the coming years. So it's a huge growth coming, and what are the key players? The key players are Texas Instruments, MediaTek. All these big companies have put all their effort, their money to grow. As I said, companies at the global level, the companies in the telecommunications sector, the VLSI sector, the computing sector, like the cloud computing, they have all thought of investing huge sums of money so that they can adopt the latest technology like 5G and other chip manufacturing technologies. See, so that's where the growth story is coming, and that's why we need people, we need trained people, the skilled people to who can enter into the industry with a design experience, with a lot of project-based experience, so that they can design and they can produce good products. That's the consumer, again, that is the consumer market I'm talking about. Look at the growth story happening in the consumer market also. The mobile phones, the digital cameras, the air conditioner, everything is going to be put on internet. Your refrigerator, your even your tennis rackets, even your washing machine, everything will be there on internet, which will form a huge network of Internet of Things. That's the kind of the technology, that's the kind of scene will change around us. Okay, now after discussing all this growth that is coming, we have now how electronics and communication engineering department is putting up its infrastructure, is creating an environment which can take care of all these technologies, so that they can inculcate all these things into the knowledge base of the students. Now we have different and sophisticated labs in the department, like digital electronics lab, microcontroller and embedded systems lab, as digital signal processing lab. All these labs are equipped with the latest technology, instruments, the boards, the kits, the computing systems, communication lab, wireless communication lab. We have a huge VLSI design lab with all the latest kind of softwares available. We have artificial intelligence lab, where we are working upon different the latest things happening in the AI. We have got general purpose, the graphic processing unit, high-end graphic processing units, IoT lab. So if you look at the lab infrastructure that I'm trying to present here, and if you compare the previous slides, they are going in tandem with each other. We have developed the labs, and we have developed the curriculum, so that we can just match our teaching with the whatever is happening in the industry. So major thrust areas are antenna engineering and micro electromechanical systems, then fiber optic communications, nano semiconductor devices, signal processing, 5G and 6G wireless. A lot of our faculty members are doing research in this area, in these areas. VLSI system and circuit design. Then about the computing technologies like artificial intelligence, machine learning, computing, then edge computing. So we have a complete, package of faculty infrastructure, which can, teach the students, and the students can really, enjoy the kind of teaching. And that's why I call this studying this electronics, computing, and communication as a real transformative experience. Once you join the department, you will really feel it. And this is about the university rankings. Already Dr. Batish has touched upon this, that we are falling into the world ranking university. We are falling in the world rankings also. And the ranking is, focused, the ranking is coming out of the academic reputation, the employer reputation, research citations per paper, which the faculty members publish, and the H index of the university itself, the faculty members. Then 90% of the students of electronics and engineering, communication engineering department, along with ENC, because we will start the electronics engineering specialization VLSI this year, but earlier we were running two programs, the electronics and communication engineering and electronics and computer engineering. So most of the students are placed, and rather I would say every student is placed who is eligible. And the highest package that the student has got is about 40 lakhs. Average package is around 11 lakhs. And, good percentage of students are pursuing their higher studies in prestigious institutions in India and abroad. I know many of these students going to Stanford University, Carnegie Mellon, and Stony Brooks. I mean, you name the university, our students are going for higher studies. Students are also getting 6 months industrial internships with, internships with a stipend of, let's say, 1 lakh per month. People are going to NXP, people are going to Intel, those kind of industries, the students are going for internship. They have got an opportunity to go for their startup, to establish their own startup through a venture incubation lab that the institute has set up. And most of the students will get the pre-placement offer during their industrial internship only. So these are the career prospects which the students can opt for, and the students, as a faculty member, at least I can tell that the students go into these areas like education for masters, they go for research oriented jobs, then private core companies, Synopsys, Siemens, Nokia, Microsoft, Google, Amazon, you name any company, you will find that it is coming to Thapar, and the Thapar students are placed there and doing extremely well in these industries. Then these are some of the private industries which you can, which our students, which come here for recruitment also, and the students go there, like D-Shaw, Microsoft, Cadence. These companies, the students go there. The students also go for government and public sector companies like ISRO, CDAC, DRDO, state government institutions. Maybe some of these students go for the civil services examinations also, IES exam. And then this is same kind of slide, people go. And so what are the, this is important, what are the initiatives that because I have talked about the technology part, I've talked about the company, what are the initiatives that the department has taken so that they can meet the expectations of the students. The first part is updating the curriculum. The curriculum is structured in such a way so that the curriculum, whatever is taught to the students, that meets the demand of the industry. And we have on our board of studies people from the industry who guide us to design the subjects, to design the curriculum. And about the ECE, about the electronics and communication engineering, we have elective baskets so that the student can choose one of the basket and can pursue their studies into one of the core areas like signal processing. So these are the core electives that the student can choose. Computing, if the student is interested in the computing kind of courses, this is, I'm talking about the electronics and communication engineering. Courses like data structures, operating systems, machine learning, database management, cloud computing. Then there is another basket, which is VLSI basket. Then there is one specific basket for communication systems where the students can go for communication kind of industry. They can go like microwave engineering, NFV, NSD, and wireless sensor networks. And this is about the core courses which the electronics and computer engineering students will take up. Of course, there are other courses. I'm just trying to mention some of the important courses where you get a feel that the electronics and computer engineering students or ECE students are really well equipped. You know, their knowledge base is in the electronics sector also and in the computing sector also. So they can, you know, appear in any recruitment company which is coming for their recruitments also, and they can, you know, join in. See, the important thing is that once you are opting for electronics and communication or electronics and computer engineering, you are trained for two core fields like electronics and computer also, right? So specific courses, the specialized courses which we offer to the ENC students are network security, algorithm analysis and design, compiler construction, augmented and virtual reality, software engineering, network function virtualization and software-defined networking, cloud computing, blockchain technology, natural language processing. All these courses are related to the computer science and computer engineering. And look at this part. The electronics and computer engineering students will also study at the same time courses like signals and systems, digital signal processing, digital communication, where they will be trained for electronics part also and for the computer. So that's an added advantage to the students who opt for electronics and computer engineering and even for ECE students. Now, these are some of the very specialized courses for the BE that we are starting this year only, BE Electronics Engineering with a specialization in VLSI design and technology. Look at the courses. The courses are like mixed signal circuit design, RF circuit design, VLSI testing, verification and validation. All these courses, you know, are the core courses for electronic design. And companies like Texas Instruments, companies like Analog Devices, NXP, companies like Motorola, you know, are looking for people who can work in these areas. And we have specialized faculty who can teach these courses. And the students, you know, they are serving that industry to a great extent. We have a lot of alumni base also in these VLSI industry also. Then at the same time, we have industry-sponsored subjects also like financial derivative. So these are the optionals that the students can choose, which the industry will teach to our students. Courses like financial derivatives, and these are some of the courses like finance and accounting, finance and derivative markets, pricing, trading and strategies. Then development, this will be with the ZVIA collaboration, full stack development. This is a course, you know, these are courses, some specialized courses where once the student gets trained, they will be directly, you know, working on the high-end computing computing systems like cloud computing, the database engine, the test automation, the courses like data analytics, natural language processing. All these courses will be offered by industry as an optional. Students can choose to opt for these courses. Then the department is working on some centers of excellence like big data, smart cities, animation and gaming, food security. It's the overall centers of excellence of the Thapar Institute, actually. advanced manufacturing, emerging materials. Now, as Dr. Batish has also touched upon, that the students are learning from experiential learning or project-led learning. See, this is how the students are engaged into the projects. The students are working on the robots. The student, this is the antenna system that they are working on, and this is particularly to the signal processing, digital signal processing lab. So students will have to do two undergraduate programs in their first 2 years. One is the Buggy project, which Dr. Batish has also mentioned, Mangonel project, which is a catapult project. Then they have to also do minor projects. Another, added advantage of doing degree or studying at Thapar is the experiential learning, where the students, where we have, established a full-fledged experiential learning center. As Dr. Patiala said, we have hired faculty from Waterloo University, Dr. Sanjay, who is guiding us on, the experiential learning kind of projects which the students develop, and they work at the PCB design level, PCB fabrication level, and these are some of the projects that the students have done in their ELC activities: robotic arm, FM receiver, and IoT based automation. Then in the final years, they will have to do a capstone project where, for example, they have studied, let's say 35 subjects. So out of 30, 35, 40 subjects, they will have to choose 5 to 10 subjects. They will use the knowledge base of those subjects, and they will apply that knowledge base to develop a larger project, which we will call as the capstone project, which will be a full semester project. And they gain a lot of experience out of this part of the capstone project. Then these are some of the pictures which you can see that the students are. This is the catapult project where the students are. Where this is the electronics part, where the students will learn about the calculation, how they can interface the electronic hardware with the mechanical system, which is a catapult, and they will measure the angular velocity of the throw that will be done by the catapult. This is the catapult. The competition will also happen where the students will be judged based on how far they can throw their target, and with how much accuracy they can throw the projectile. Then this is the Buggy project, which the students will do in their first 2 years only. They will develop the software with different challenges that is in the software design that we will give to the students, about the track they will follow, about the obstacles that will come into the path, and how they will make the buggy to run in a perfect manner. This is the buggy track that they will have to, every time we will change the problem, and the students will have to write the program either in C or C++ to make the project. And these are some more pictures showing the students working at different projects. Then this is the ELC activities that will happen about the PCB fabrication and all. These are these pictures are showing the ELC activities for the IoT system. We have a full-fledged lab of Internet of Things based systems, where the students will learn starting from the sensors to the processing units and the implementation part. That's all from my side. Thank you so much for your